Hi, welcome to my channel pibyme Maths. This is Demon. Here we are solving January-February 2020 Pure Math 2 paper. In the previous video we have covered question number 1 to 5 already. Let's look at question number 6. We have an equation of a circle. Find the coordinates of the center. You can apply completing the square, or the easiest way is take the coefficient of x as 2f, coefficient of y as 2g. Find f and g. So the center is minus f, comma minus g is the center. So minus 3, comma positive 2. Change the sign of f and g. That's the easiest way to find the center. Now for radius, the formula is square root of f square plus g square minus c. C is this number. So f square plus g square minus of minus 14, which becomes plus 14, right? So that's square root of 3 square, 2 square, 14 is 3 root 3. Let's move on to part B now. The line with the equation y is equal to k is a constant. K is a constant, is a tangent to C. Find the possible values of k. Okay, I'm going to show you the little diagram here. We have a circle with center 2, minus 3. Okay, that means let's say the y coordinate is here. We don't know where the y coordinate is. Let's say the y coordinate is here. The y coordinate here is 2, right? Y axis here, the y coordinate is 2. If you take a line y is equal to k, it can be here, it can be here like a tangent, because the question says it's a tangent, or it can be here, right? We know the radius of the circle is 3 root 3. The length of the radius is 3 root 3. So this coordinates definitely should be 2 plus 3 root 3. Or this coordinate would be 2 minus 3 root 3, because the length from the radius to this point of touching, point of contact, is 3 root 3, right? So this is the line y is equal to 2 plus 3 root 3. This is the line y is equal to 2 minus 3 root 3, right? So you can write therefore y is equal to 2 plus or minus 3 root 3. That's all. You don't need to do anything else. Just a 2-mark question. Now there is one more way you can find this value. Since this tangent to the circle, sub in this into the equation of the circle. Replace y by k. So you're going to get x square, sorry, not here. You are going to get x square plus cx plus y square minus 6y, y square minus 4y minus 14. Minus 14 is 0. Here a is the coefficient of x square, b is the coefficient of x, c is the constant term, which is k square minus 4k minus 14. Since these two are tangent, the condition is b square minus 4ac is equal to 0, right? So 6 square minus 4a is 1. C is equal to 0. And solve for k, you are going to get 2 plus or minus 3 root 3, because it's a quadratic equation. That's another way actually. But since it's just a 2-mark question, you don't need to do all this work. You can just write the answer straight away. Part C now. The line with the equation y is equal to p is a negative constant, is a chord of C. Given that the length of the chord is 4 units. Okay, wait. We know the radius, the center of the circle is minus 3, 2. So I'm going to draw a little figure to understand this. Let's take a circle with center minus 3, 2. So let's say, and we know the radius is 3 root 3. Okay, 3 root 3 is 5 point something, right? So definitely the y should be somewhere here, and x has to be here. x and y, because this length is 3 but the total length is the radius, which is 5 point something, right? Okay, now we have a chord y is equal to a negative number, so it has to be a line parallel to x-axis. The chord is parallel to x-axis because of y is equal, the equation is this, right? So let's take the chord somewhere here. Let me take the chord here. Okay, the length of this chord is 4. If you draw a line from the center, if you draw a line, a perpendicular line, it will bisect the chord. That's a circle theorem, right? So this will be 2, this will be 2. And if you connect these two lines, that's the radius, 3 root 3. So using Pythagoras theorem in this triangle, right angle triangle, we can find this length, right? This length, let's say A, the length from C to P. So you can write 2 square plus A square is equal to 3 root 3 whole square. So A square is, this is 27 minus 4, that's 23. A is square root of 23. This length is square root of 23, right? Okay, we got the value of CP as square root of 23, right? We know this is 2. This length is 2, the total length is 23. So this coordinate is going to be 2 minus square root of 23, right? So P is equal to 2 minus square root of 23. That's the easiest way to find P. Question number 7 now. Show that this equation can be rewritten in this form. So I'm going to take the whole equation and replace tan by sine over cos is equal to 3 cos theta. Bring the cos here. So 8 sine theta is equal to 3 cos square theta. We can replace cos square by 1 minus sine square using the identity cos square plus sine square is 1. Open the bracket and move everything this side. Minus 3 plus 3 sine square is 0. We got the equation. 3 sine square theta plus 8 sine theta minus 3 is 0. That's all. Part B now, hence solve this. In part A, we have rewritten this equation. 8 tan theta is equal to 3 cos theta into 3 sine square theta plus 8 sine theta minus 3 is 0. We have rewritten this equation into this form. So how do you rewrite this equation? Because it's the same equation, right? Only thing, in the place of theta you have 2x. So you're going to get 3 sine square 2x plus 8 sine 2x minus 3 is 0. That will be the equation. Take the equation from part A, replace theta by 2x. Now this is a quadratic equation. I'm going to solve it. 3, 8 minus 3. 1 over 3 and minus 3. Sin x is 1 over 3. Sin x is equal to 3. You can write the factors 3 sin x minus 1 times sin x. This was minus 3 actually. Plus 3 is 0. Now we need to solve these two equations. This has no solution because the range of sin x is minus 1 to 1. We are going to solve only this equation. I made a slight mistake here. It has to be sin 2x, not just sin x. So we are going to solve this in this limit now. To solve that, let's take the equation sin 2x is equal to 1 over 3. Multiply the limits by 2. You'll get 180 degrees. Find the principal value. 2x is equal to sine inverse of 1 over 3. Use the degree mode. Sine inverse of 1 over 3. 19.47. 19.47 dot dot dot. Do not round the figure. I'm going to store the figure as A. Now use the ASTC diagram. The limit is 0 to 180, which covers all the 4 quadrants. and sine would be positive in here and here. It's theta and 180 minus theta. So 2x is equal to 19.47 theta, 180 minus theta. Theta is a principal value. Calculate this and divide by 2, round it to 2 decimal places. So therefore x is equal to answer divided by 2, which is 9.74 degree. And then pi minus, I stored the principal value as a, divided by 2. Sorry, it's 180. Don't put pi. 180 minus a divided by 2. 80.3. They want the answer to 2 decimal place. 80.26. That's all. Question number 8. An arithmetic series has first term a, common difference d. Prove that this formula. This is a formula for sum of n terms which is given in the data booklet. They will ask you to derive the formula. They might ask you to derive the formula for the geometric series also. Okay. So what you need to do first, write Sn. The first term plus the second term, sorry, a plus d is the second term. A plus 2d plus dot 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 dot. The nth term will be a plus n minus 1 times d. Right? The previous term will be a plus n minus 2 times d. Write the previous term also. Now I'm going to write Sn again, but this time I'm going to flip the whole series by writing the last term starting from the last term. So a plus n minus 1 times d plus a plus n minus 2 times d plus dot 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 plus a plus 2d a plus d plus a. I have rewritten the whole series starting from the last term. So if you are wondering why I am doing that, when you add this, 2Sn is equal to, when you add this term, the first term with this first term, a plus a 2a plus n minus 1 times d, right? Plus. When you add this term and this term, a plus a is 2a. You have d plus n minus 2 times d. You open the bracket, you will get d times nd minus 2d. It is going to be nd minus d, which is n minus 1 times d. You don't need to show anything. Just write the same term again. Okay, you don't need to show this work. So every term will be 2a plus n minus 1 times d. Every term. So how many number of terms there? There are n terms, n similar terms. So you can write it as 2Sn is equal to n times 2a plus n minus 1 times d, because there are all these n terms are similar terms, right? Divide by 2, you got the answer already. Sn is n over 2, 2a plus n minus 1 times d. That's a 3-mark question, that's all. Double I now. A sequence is given by un is equal to this. Find the value of u5. Okay. It's not a iterative formula. It's more like the nth term. So you replace n by 5. So u5 is going to be 5 times 5 plus 3 times minus 1 power 5. 5 times 5 is 25, minus 1 power 5, minus 1 power odd number is negative 1. So 25 minus 3 is 22. That's the answer for part A. Part B now. Sigma n is equal to 1 to 59 un. Sigma n is equal to 1 to 59 un. I'm going to replace un by this formula. 5n plus 3 minus 1 power n. Split the sigma notation. You can write it as 5 sigma n plus 3 sigma minus 1 power n. If you have AR plus B, you can split it as A sigma R plus sigma B. You can split the terms actually. So 59n is equal to 1, 59n is equal to 1. Okay, now if you write out all the terms, replace n by 1, n by 2. So this series is going to be 1, 2, 3, etc. till 59 plus 3 times. If you replace n by 1, you will get a negative 1, positive 1, negative 1, positive 1, etc. etc. The last term will be negative 1 because power 59, right? The previous term will be plus 1 and then the 57th term will be negative, right? Okay. The first one is arithmetic series. There are 59 terms. So the formula is n over 2 a plus l. First term plus the last term plus 3 times. Here minus 1 plus 1, minus 1 plus 1, minus 1 plus 1. Everything will be cancelled. You will be left with the last term minus 1. That's all. Okay. You don't need to write this, just put minus 1. And then simplify this. You will get the answer already. So 5 times 59 over 2 times 60 minus 3. 8,847 is the answer. Question number 9. Sketch the curve and show the coordinates of the point of intersection with coordinate axis. Okay. Draw the xy axis. Always label the graph, label the axis first on the origin. This is the graph 4 power x. So 3 times 4 power x. It's a stretching actually. So you can still show the same graph. Y is equal to 3 times 4 to the power x. If you replace x by 0, it's going to be y is equal to 3 times 4 power 0 is 1, 3. So this point will be 0, 3. Put it in the coordinate form. That's all. They will just look at the shape of the graph and then the coordinate will be given 2 marks. Part B. This curve meets this curve at point P. So we need to equate them. 6 power 1 minus x is equal to 3 times 4 power x. And make x as a subject, so you will get x coordinate as this. Put the 1 minus, by apply logarithm both sides. Log 6 to the power 1 minus x is equal to log 3 times 4 power x. I did not write the base for logarithm because the default base is 10, right? We need base 10. You can put this power in front. 1 minus x log 6 is equal to, here log a times b is log a plus log b, but you can put the x in front, so you can write it as x log 4. Hope you understand this step. So open the bracket, you are gonna get log 6 minus x log 6 is equal to log 3 plus x log 4. So I'm gonna bring this term here, becomes positive, log 3 here. So I'm gonna get log 6 minus log 3 is x times log 4 plus log 6. I have take x as a common factor. So log a minus log b is log a over b. 6 over 3 is log a plus log b is this, right? So x is basically 6 over 3 is log 2. Now put the base divided by log 6 4s are 24. That's all. It's a 5-mark question. Question number 10. We have a function given y is equal to 4x cubed minus 9x plus this. Point P with the x coordinate 1 over 2 lies on C. P is a stationary point. So how they got this x coordinate? You need to take dy over dx, equate it to 0. That's how you got this stationary point, right? Okay, that's what we are going to do now. To find the value of k, take y first. 4x cubed minus 9x plus kx power minus 1. dy over dx is equal to 0. When it's 0, when x is equal to half, right? Because that's the x coordinate of the stationary point. So first we can just find dy by dx actually. 12x square minus 9 minus kx power minus 1 minus 1. Now you write dy over dx is equal to 0 when x is equal to half. So 12 times half square minus 9. This is basically minus k over x square, right? So minus k over x square is 0. Make k as a subject. So 12 over 4 is 3 minus 9 is minus 6. This 4 goes to the top. 4k is 0. 4k is 6. 4k is minus 6. K is minus 6 over 4. We got the answer already. Part B, determine the nature of the stationary point. To find the nature of the stationary point, we need to find the second derivative. We have the first derivative, 12x square minus 9 minus k x power minus 2, right? But we know k is minus 3 over 2. So sub in here. Plus 3 over 2 x power minus 2. Differentiate one more time. We're going to get 24x. This becomes 0. When you differentiate this, you need to put minus 2 in front. So 2 will be cancelled. Minus 3 x power minus 3. So when x is equal to x coordinate of the stationary point, when you sub in here, you're going to get 24 times half minus 3 over x cubed, which is 24. So you're going to get 12 minus 24 is minus 12 is a negative number. Therefore, it's local maximum. Local maximum. If the number is positive, it's local minimum. That's all. Just a 2 mark question. The last part. The curve C has a second stationary point. Use algebra to find the x coordinate of the second stationary point. We are going to take the dy over dx and equate it to 0 with the k value. So it's 12x square minus 9 minus kx power minus 2. K is minus 3 over 2. So it's going to be plus 3 over 2x power minus 2 is 0. Multiply. Okay, this is going to be 12. Multiply through it by 2 first. 24x square minus 18 plus 3 over x square is 0. Multiply through it by x square again. 24x power 4 minus 18x square plus 3 is equal to 0. 3 8s are 24. So divide 2 out by 3, you'll get 8x power 4 minus 6x square plus 1 is 0. Take p as x square, so p square will be x power 4. So this equation becomes 8p square minus 6p plus 1 is 0. Solve the quadratic now. 8 minus 6, 1. 1 over 2, 1 over 4. P is 1 over 2, p is 1 over 4. Both are positive number, right? Yep. So it's going to be 2p minus 1 times 4p minus 1 is equal to 0. Replace p back to x square. X square is 1 over 2. So x is plus or minus 1 over square root of 2. X square is 1 over 4. X is plus or minus 1 over 2. So now that's when you need to go back to the question. It says x is positive. So there are two options. X is positive 1 over root 2 or positive 1 over 2. But we know 1 over 2 is a x coordinate of point P, right? So therefore the answer, the x coordinate of the other stationary point is 1 over root 2. That's all.